Talk about functions with radicals. So those are things like addition, subtraction, multiplication, and division. First, we're going to talk about multiplication and division. So if I have a problem like 5 radical 3 times 8 radical 21, I have two ways that I can do it. The first way is to multiply like parts. So that would be the 5 and the 8, and the radical 3 and the radical 21. And that gives me 40 times radical 3 times 21, which is 40 radical 63. And then 63 I can break down as, let's see, 40 times radical 9 times 7, which equals 40 times radical 9 times radical 7. Radical 9 is actually equal to 3. So that's 40 times 3 times radical 7, which gives me 120 radical 7. So the first way is to multiply the like parts, so your whole numbers and your radicals, and then simplify the radicals. The other way to do it is to actually kind of break down your radicals at the same time that you multiply. So I would do 5 times 8 over here. And then I would do radical 3 times, well, 21 is actually 3 times 7. And so I would break that down over here. And radical 3 times radical 3, as we know, is 3. So I get 5 times 8 times 3 times radical 7. And I would get 120 radical 7. So either way I want to do that is correct. Let's look at another problem. What if I have a problem like this? The square root of 10 thirds times the square root of 27 over 32. So I'm going to combine them under one radical. And I'm going to go ahead and break down a few things. That's 10 times 3 times 9, because 3 times 9 is 27. And then that's 3 times, well, 32 is 16 times 2. So I'm going to leave that like that. And you'll notice that I left these two here off on their own because they're perfect squares, and I kind of noticed that. But whether or not you notice that is okay for now. So my 3's are going to cancel out. And let me redo that. And my 10 and my 2 are actually going to simplify to a 5 and a 1. So I end up with the square root of 9 times the square root of 5 over the square root of 16, which gives me 3 radical 5 over 4. Not nearly as scary looking. Alright, let's try another problem. What if I have a problem involving some variables? So I have 4 square root of a squared b squared times 3 radical b. Well, I already know that I can go ahead and simplify that a squared b squared. So I'm going to do my 4 times 3. I'm going to do my absolute value of AB. We'll go ahead and put it in one pair for you. And then I'm going to have my radical b left over. So my answer would just be 12 AB radical b. Simple enough. What about this problem? Square root of x times the square root of x minus 3. So now I've got a little distributive property I got to remember, and I'm going to get the radical x times radical x. So that's really the square root of x squared. And then I distribute that radical x to the 3, and I get minus 3 radical x. So the square root of x squared, remember, is just x. So I get x minus 3 radical x. Alright, in the next video we're going to do some more problems. So we're going to do more with radical functions. Let's look at another problem. What if I have the square root of 75 divided by 2 radical 18? So first thing I want to do is simplify those radicals. So that's going to be the square root of 25 times the square root of 3 over 2 times the square root of 9 times the square root of 2, which gives me 5 radical 3 over 6 radical 2. So that looks like that's almost as far as I can go. But it's not simplified. And how do we know when a radical expression is simplified? Well, if there are no perfect squares as factors of the number under the radical, so we don't want square root of 8. That's not simplified because 8 is 4 times 2, and 4 is a perfect square. So that's the first way it's simplified. But there's more. We can't have a fraction under the radical. So you don't want the square root of 4/3. That's not simplified. And we can have no radicals in the denominator. No radicals in the denominator. So let's go back to that last problem. Is this simplified? Well, I have a radical in the denominator. This makes it non-simplified. So let's go ahead and simplify that. How would I get rid of that radical 2 underneath? What could I do to it to get rid of the radical? Well, remember if I took the square root of x times the square root of x, I got x. Well, the square root of 2 times the square root of 2 is going to give me 2. So I'm going to use a process called rationalizing the denominator, and I'm going to multiply the whole fraction by 1, but it's going to be radical 2 over radical 2 in this case. So I'm going to do 5 radical 3 over 6 radical 2 times radical 2 over radical 2. I'm going to get 5 radical 6, and on the bottom I'm going to get 6 times radical 2 squared, which is 2. 6 times 2 is 12. So I get 5 radical 6 over 12. This is my simplified answer. So if you have a radical on the bottom, you need to multiply the whole fraction by that radical over itself. Alright, let's move on. If you think of 5y plus 3y, what do you get? 8y. So what do you think I have when I get when I have 8 radical 11 plus 2 radical 11? Well, these radical 11s are the same. So they're kind of like the x's and the y's. They're like baseballs and footballs and basketballs. We count them together. So that's going to give me 10 radical 11. What if I have this? 7 radical 3 plus 2 radical 2 minus 3 radical 2 minus radical 3. Well, I'm going to combine like terms. So all of my radical 3's I'm going to combine together, and all of my radical 2's I will combine together. So what's 7 radical 3 minus 1 radical 3? 6 radical 3. And what's 2 radical 2 minus 3 radical 2? Minus 1 radical 2. So my answer would be 6 radical 3 minus radical 2. Let's try another. What if I have this expression? 25 radical 2 plus 2 radical 27 minus 3 radical 98. Well, the first thing I need to do is simplify everything. And that gives me 25 radical 2 plus 2 radical 9 times radical 3 minus 3 radical 49 times radical 2, which is really 25 radical 2 plus 6 radical 3 minus 21 radical 2. Combine my like terms, and I get, so my answer is 4 radical 2 plus 6 radical 3. So what happened to the plant sitting on the windowsill of the math classroom? It grew square roots. Alright, see you tomorrow.